In this video, we will move away from parametric equations and instead talk about a new coordinate system, something called polar coordinates. Now, typically if we have this coordinate grid and we have a point, we would want to represent it as x comma y, where recall what these things represent. X measures the directed distance from the y-axis, y measures the directed distance away from the x-axis. What we are going to do instead is think of these points in a new way. I'm going to think of this point as being r comma theta, where r measures the distance the point is away from the origin, and theta measures this angle we get if we start at what was formerly the positive x-axis and rotate in the counterclockwise direction. Now, note in terms of just some basic trig, so we said we had x and y. X is equal to r cosine theta, and y is equal to r sine theta. So this gives us the relationship between those Cartesian coordinates, x and y. So we think of x and y as being the Cartesian coordinates, and r comma theta as being the polar coordinates. Furthermore, by the Pythagorean theorem, we know that x squared plus y squared equals r squared. And for future use, also note that tangent of theta equals y over x. So in a moment, these formulas will allow us to take points from Cartesian equations and represent them in polar, and vice versa, take points in polar coordinates and represent them in Cartesian. But before doing that, let's just go ahead and plot a few points and get a feel for the polar coordinate system. So let's start with the point 3 comma 2 pi. And let's just recall this is r comma theta. So theta represents that angle we have starting at the positive x-axis, or what was formerly the positive x-axis, and a positive theta value means we go in the counterclockwise direction. A negative theta value would indicate that we go in the counterclockwise direction. So if we go 2 pi, we end up back on that same axis. We go once around. And then our r value is 3. So we need to be 3 units away from the origin. So 3 comma 2 pi would be the point represented here. Now note this is equivalent to 3 comma 0. So theta equaling 0 or theta equaling 2 pi would be just this former positive x-axis. Okay, on to the next point, minus 2 comma pi thirds. So pi over 3, note, is what, 60 degrees. So roughly, let's say right about here, theta equals pi over 3. But the new thing is, how do we handle this negative r value? And it turns out that if the r value is negative, instead of going along that ray theta equals pi over 3, what you do is you extend it in the opposite direction, and when the r value is negative, you go along that new ray. So minus 2 would put us 2 more units away. So on this circle of radius 2, and we would have the point minus 2 comma pi over 3. Okay, our third point, minus 2 comma minus pi over 4. So minus pi over 4 means we need to go in the clockwise direction. And because it's minus 2 as our r value, we need to extend this ray. So minus 2 comma minus pi over 4. Our fourth point, 1 comma minus 4 pi. So minus 4 pi, we start off along this former positive x-axis. Minus 2 pi brings us around 1 time in that clockwise direction, but minus 4 pi means we go around it twice. So we're still on this axis. And the 1 indicates we're 1 unit away from the origin. So 1 comma minus 4 pi. And lastly, we have the point 3/2 comma pi. So pi would put us along what was formerly the negative x-axis, because that would be pi radians, and then 3/2 units. So right about here would be 3/2 comma minus pi. So when sketching a point in polar coordinates, we typically might think of the angle first, and then once we have that angle determined, think about what the corresponding r will be, i.e. how far you are away from the origin. And a negative r value in a sense means you go in that opposite direction along the ray. Another typical question we might be asked is, if we're given a point in polar coordinates, what are the corresponding Cartesian coordinates? And recall from our introduction slide that we have the relationship x equals r cosine theta and y is equal to r sine of theta. So in polar coordinates we have r and theta. So r is 2, theta is 0. What this tells us then is that x is going to be r cosine theta and y is equal to r sine theta. Cosine 0 is 1, sine of 0 is 0, so in Cartesian coordinates our associated point is 2, 0. So note, whether you're in polar coordinates or Cartesian coordinates, 2, 0 represents the same point. And that will not typically happen, but it could occasionally happen. So similarly again here, if we look at this point 2, minus 2 pi over 3, x is equal to r cosine of theta, and y is equal to r sine of theta. And cosine of minus 2 pi over 3 is going to be minus 1/2. So that would be 2 times minus 1/2 is minus 1. And sine of minus 2 pi over 3 is going to be the square root of 3 over 2. So times 2, that would be the square root of 3. So the corresponding point in Cartesian coordinates is minus 1, square root of 3. And what I recommend to you as an additional exercise to help solidify your understanding is to go through and sketch these points and think about that comparison graphically between polar and Cartesian. So let's investigate one more example where we do, in this case, the opposite problem. We have the point given in Cartesian and we would like to convert it into polar. That is, what is the corresponding r value? What is the corresponding theta value? And the formulas to help us determine these things will be that x squared plus y squared is equal to r squared, and tangent of theta is equal to y over x. And kind of one word of warning here is with the tangent of theta, if you use arctangent to rewrite this as theta equals arctangent of y over x, arctangent is always going to give you back an angle between minus pi over 2 and pi over 2. That would be the fourth quadrant or the first quadrant. So we do have to be careful to think about, is the given point in the second or third quadrant? And if it is, we may have to adjust accordingly by adding pi. So let's go ahead and get started. So in this first point, 3 root 3 over 3. This is of the form x comma y because we are in Cartesian coordinates. So we have that r squared is equal to x squared plus y squared. So that would be 3 square root 3 squared plus 3 squared. So r is, well, let's see here, r squared is equal to 36, so r is the square root of 36, which is equal to 6. Furthermore, we know that tangent of theta is equal to y over x. So 3 over 3 square root 3, which is 1 over the square root of 3. Now, let's think about what quadrant we are in. So 3 square root 3 comma 3 is in quadrant 1. So we can simply use the arctangent formula. So if tangent of theta is 1 over 3, that's an indication that theta is pi over 6, and the angle pi over 6 does put us in the first quadrant. So in polar coordinates, that associated point would be 6 comma pi over 6. So a similar approach here for our second point. This is in the form x comma y. And note that because the x is negative and the y is positive, this point sits in the second quadrant. So we'll say quadrant 2. And we'll have to take that into account. So r squared is equal to minus 2 root 3 squared plus 2 squared. So r squared in this case would be 16, which tells us r is the square root of 16, which equals 4. Furthermore, tangent of theta is going to be y over x. So that's 2 over minus 2 square root 3, which is minus 1 over square root 3. So as above, if we use that arctangent formula, this is going to give us back theta equals minus pi over 6. But note that since we are in the second quadrant and not the fourth, our theta value is going to be minus pi over 6, and we're going to have to add pi onto that. So that would be 5 pi over 6. So that goes back to the comment made earlier that using this arctangent formula, we do have to adjust for the second and third quadrant. So because we're in the second quadrant, we add pi to get 5 pi over 6. So in polar coordinates, our point in this case would be 4 for the r value, 5 pi over 6 for the theta value. And the same comment goes as the previous example. A good additional exercise to help solidify your understanding would be to sketch these points and once again think about the relationship between the polar and Cartesian coordinates.